Hello everyone, welcome to day 23. Today I'll be doing sliding window questions and we'll continue with this series. So let us go with the first question. Okay, so the first question is maximum sum of distinct subarray with length k. You are given an integer array nums and an integer k. Find the maximum subarray sum of all the subarrays of num that meets the following condition. The length of the subarray is k and all the elements of the subarray are distinct. Return the maximum subarray sum of all the subarrays that meet the condition. Okay, so basically we need to find the maximum sum. So this is a valid subarray because all the elements are distinct. Then we need to find the sum of all the elements in this, and similarly we need to find the sum of all the elements in this and find the maximum of all of them. And the size of the subarray should be k. A subarray is a contiguous non-empty sequence of elements within an array. Okay. So first thing first, what we can do is in the brute force approach, we find all the subarrays of size k in this array, and then we check if there are any duplicate elements in that subarray. So for example, as this is the subarray, this is the first subarray, and then we can check if there are any duplicate elements in that subarray. For that, how to check if there is a duplicate element in a subarray? For that we can take a hash map, or we can take a hash map. Okay, and we can keep count of each element, and then we can iterate over that hash map and see if there is any element with the count with a different count, and like count is greater than 1, and for that element, that means that that element is present more than once, so we will not consider it as a valid subarray and move to the next subarray, which is this one. And for finding the subarrays, we can have two pointers, one at the start and one at the kth index or k minus 1th index, because if k is 3 we need the till second index, so 0 to 2. So we'll take two pointers, one here and second here, and at each iteration we'll move both the pointers, and will after moving the first pointer we will remove this from the hash map, because this we are not considering in the next subarray. So we will remove this from the hash map, or remove the count of this from the hash map, and will include the next one. And then again we'll iterate over the hash map and check if there is any element with the count greater than 1. If that is true, then we will not consider this as a valid subarray. And at each iteration we can one thing we can do is again iterate over this and find the sum, or we can keep a current sum. Okay, and we'll remove this from the sum and add this element in the sum, and at each iteration we can check if it is greater than max, current sum is greater than max, then that will be the answer. But in this case we are iterating over the array, so time complexity is n, but we are iterating over the hash map as well, so time complexity will be n square, which is not good. The other approach would be that somehow if we can check if all the elements present in this are unique, like we don't have any duplicates in the subarray without going through each element. So for that, what we can do, maybe we can use a set, because in set data structure, or we can use a hash also, right? And we can keep track of a duplicate. So let's say if we take a hash map and we put all the elements, so we'll keep both the pointers, and at each iteration we'll remove the last element. If let's say in the hash map, if the element which we are removing, we will find the count of that element. If it is 1, then we'll remove it. If count is 1, then we'll remove that element. But if count is greater than 1, then we will update the count. We'll update the count by count minus 1 of that element. And similarly, we need to add the to move the pointers, we also need to move the second pointer and add the next element. So we'll check in the hash map, if this element is present, already present, then we will update the count. So count will become count plus 1 for this element. And if it is not present, then count will become 1 for this element, right? Count will become 1 for this element if not present. And one more thing, we'll keep track of a variable, let's say call it duplicate, and instead of going through the whole hash map, iterating over the whole hash map to check if any element is duplicate, if any element is present twice or not, what we can do is we can keep track of a variable called duplicate initially as 0, and at each iteration, whenever we see that count of any element is moving as more than 1, so we will update duplicate, we'll do duplicate plus plus. So if any at any index, let's say when we are adding, in case of addition, when we are see that that element is already present and count is increasing, that means there is a duplicate present in the hash map. So we'll update duplicate as well as duplicate, we'll do duplicate plus plus, and while we are removing an element and we see the count is greater than 1, and that means we are removing a duplicate, so in that case we'll do duplicate minus minus, right? And at the end, in each iteration we'll check if duplicate is still 0, that means if duplicate is 0, that means now in the hash map there are no duplicate elements, because we have, if they were there, it is again reduced to 0, or if that is the case. So if duplicate is 0, that means in the hash map at this present time there are no duplicate elements, so we can check, we can update max to max of both current and max. And at any iteration, if duplicate is non-zero, that means there is some duplicate element. So this is one way of doing this, but while I was thinking about this, I came up with one more idea, that instead of doing this, what if we can also, instead of keeping track of duplicate as a separate variable, we can also check the size of hash map. So if there at each iteration the size of hash map will be what? Hash map ka size, if we check, so the size will be k, because we are adding k elements, right, in the hash map. At each iteration, at the first sub array there will be k elements in the hash map. Even in second iteration there will be k, in third there will be k elements in the hash map, because at each iteration we are removing one and adding one element. So at each iteration there will be k, but at this iteration there will be 2 elements, not 3 in the hash map. So at any iteration, if there are less than k elements in the hash map, then there is the duplicate is present. Otherwise, if the size is k, then there is no duplicate, and we can consider this as a valid subarray. I think this is a good solution. But one more thing, so why do we need to keep count of elements? We are not using it anywhere. So instead of using hash map, we can use set data structure, because I think in Java set data structure stores unique elements. So even if we push 2 nines, it will store only 1. So at each iteration in it, the set will have unique elements, and with size of set we can check if there are k elements, that means it is a valid subarray. So let's do that. I think that is the best solution for this. So for each iteration, we'll insert one element in the set, remove one element from the set, and we can check if the size is correct. If the size is k, the size of set is k, that means it is a valid subarray, and we can update the max accordingly. So I'll write the code for this. I think this is a good solution for this. The time complexity will be order of n. I'm not sure what is the time complexity of finding the size of set, because that is what we are doing at each iteration, and inserting and removing elements from the set, that will also include it, will be included in the time complexity. Let's check that. I think it will be log n if it's using binary search or something like that. Time complexity of adding and removing elements from set in Java. Hash set may offers order of 1. Okay, add and remove order of 1. Though the worst case will be order of n if many hash collisions occur. Okay, fine. We will be using hash set only. So in case of this, it is order of 1. Fine, so we'll use this. First of all, I'll take a int max equals to 0, because we need to return 0 if there are no results, and k is always less than the size of nums, right? K is less than nums.length or equal to. And what else? We need a set. So set integer set equals to new hash set. Fine. And we need to add first k elements in the set, because once we start iterating over this array, then we won't be able to add, right? So I'll add the first 3 elements or first k elements in the set in the first go, and we also need the sum of all those elements. So we'll also take int current sum equals to 0 for int, and for int I equals to 0, I is less than nums.length. Wait, I is less than k, because we only need to add k elements, k plus plus, and we will add those in the set. So set dot add nums I. Okay, and we'll do current equals to current sum plus equals to nums I. And what is the size of this? It is 10 to the power 5 nums I. So that means it could go outside the allowed size of integer. So we'll max value of integer, sorry, so we'll take it as long. Current we have updated. Now we need to update current sum as if set dot size is equals to k, that means all the elements were unique in the first. This is the first iteration. This is what we have right now in the set. So if there are 3 elements, that means all of them were unique. Then we can update max. So max equals to math dot max between max and sum, max and current sum, right? Now we need to start doing the second. We'll start adding one element and removing one element. So at each iteration, we'll take 2 pointers. First pointer will start from the start, and in second pointer will be at k initially, or k minus 1, right? Second will be at k, because we need to add that. So second will be at k. And now let's do a while. So while second is less than nums dot length, second is less than nums dot length, Um, Now what we need to do, we need to remove the previous element and add the next element. So we need to set may say we need to remove the first element nums first, and set may we need to add the second element, so nums second is added. And at each iteration we need to check if set dot size, so same thing, if set dot size is k, that means all the elements are unique and we can update max. And at each iteration we need to increment the first and second pointer, so first plus plus and second plus plus, and at the end we can return max. That's all. We'll run this. Time limit exceed y. This should be I plus plus. Something went wrong. Let's see. Second is less than nums dot length. Is this correct? Second is moving ahead, so that will reach the end first, so this is correct. And we are removing the first and adding the second, and we are checking the size. If size is k, then we are updating max. Oh, we are not updating the current. We need to update the current also, right? Oh, current sum equals to current sum plus nums and minus nums plus nums second and minus nums first. This point was missing. Wait a second. So okay, 1 second, it will not work because if it is inserting it only once, so it will remove only once. No, once we remove 9, it will get removed. Makes sense. So it will not work for such cases. I'll have to rethink about this. So once we have this, initially there will be only 9 in the, so if there are multiple 9s, we cannot remove it right away. Because once this is added, Hmm. I don't think this will work because we need the count of elements. At each iteration, we need the count of elements. Otherwise, how we will know if something is removed, something was present two times, and then if even if it is present two or three times, we have already removed it. We need to remove only that many numbers which were present. I think the solution I said about having duplicate variable. What if we check with the size of hash map? Is it going to work? I think that will work if we take a hash map and keep the frequency of elements. In that way, we can check uh, because we have the frequency, so we will only update the frequency instead of removing it from the hash map, because in set we don't have the frequency. So even if we have got multiple elements with the same value, even if we get to remove only one, we are removing the whole all the elements. So basically, like, we don't have the count, so we don't know how many we need to remove. Or if we have encountered three nines, and if we want to remove 9, so we should remove only one 9, and 9 shouldn't be removed from the set, but it is getting removed, um, which is not correct. So we need the size or the frequency of elements. So instead of set, let's say we take a map of integer and integer. Map equals to new hash map. Okay, and initially we'll add all the elements. So map dot put, I think it is right. Map put java, or is it map dot put? Put is correct. Map put, हाँ ठीक है. So map में no, we cannot put it like this. We need to check if it is present. गेट और डिफ़ॉल्ट वाला मेथड कैसे लिखते हैं? गेट और डिफ़ॉल्ट इन मैप. लेट मी डू इट सिंपली. सो यहाँ पे सबसे पहले हम चेक करेंगे इफ़ मैप कंटेन्स दिस वैल्यू. सो मैप कंटेन्स के नॉट के नम्स आई. अगर मैप में ऑलरेडी प्रेजेंट है, देन विल अपडेट इट. सो मैप डॉट पुट मैप डॉट गेट nums i प्लस 1, और ये तो वैल्यू हो गई और की होगी nums i. तो ठीक है. एल्स इफ इट्स नॉट देयर, देन वी कैन सिंपली पुट मैप डॉट पुट nums i and 1 i and 1. ठीक है. अब इसके बाद अगर मैप का साइज़ k है, दैट मीन्स ऑल एलिमेंट्स आर यूनिक. अब यहाँ पे हम क्या करेंगे, ये सही है. अब हम ऐसे रिमूव नहीं कर सकते. वी नीड टू चेक इफ़ फर्स्ट ऑफ ऑल विल चेक रिमूवल का केस, ठीक है, मतलब फर्स्ट वाले का. सो इफ़ मैप डॉट कंटेन्स तो होगा ही, फर्स्ट तो होगा ही मैप में. कंटेन्स हमको चेक करने की ज़रूरत ही नहीं है बिकॉज वो डेफिनेटली प्रेजेंट होगा बिकॉज हमने वो ऐड किया है. सो मैप डॉट गेट करेंगे, गेट मैप डॉट गेट nums I. अगर ये ग्रेटर देन 1 है दैट मीन्स डुप्लीकेट्स वर प्रेजेंट. ग्रेटर देन 1 है तो हम मैप डॉट पुट कर देंगे -1 करके. सो मैप डॉट पुट nums I एंड nums I सॉरी मैप डॉट गेट nums यार nums I -1 है ना. मैप डॉट पुट करेंगे nums I और मैप डॉट गेट nums I -1, ठीक है. अगर ये ग्रेटर देन 1 से, एल्स हम सिंपली उसको रिमूव कर देंगे. सो मैप डॉट डिलीट होता है, आई थिंक मैप डॉट डिलीट होता है. मैप डॉट डिलीट nums I, ठीक है. अब ये तो हो गया हमारा रिमूवल के केस. अब एडिशन के केस में भी हम चेक करेंगे कि इफ़ वो ऑलरेडी प्रेजेंट है. सो इफ़ मैप डॉट कंटेन्स की nums I, तो उस केस में हमको nums I, इस केस में हमको वैल्यू अब इंक्रीमेंट करनी है. सो सेम चीज़. अब एक सेकेंड, यहाँ पे आई नहीं होगा, यहाँ पे फर्स्ट होगा. यहाँ पे हम फर्स्ट के लिए चेक कर रहे हैं ना, तो ये होगा फर्स्ट. यहाँ पे भी आएगा फर्स्ट और यहाँ पे भी आएगा फर्स्ट और यहाँ पे आएगा सेकंड, है ना. एल्स और ये हमारा हो जाएगा, अगर कंटेन्स की है तो हमारा इंक्रीमेंट हो जाएगी वैल्यू, इसका फ्रीक्वेंसी. और अदरवाइज़ हम पुट करेंगे मैप डॉट पुट nums सेकेंड 1. अगर नहीं है तो फ्रीक्वेंसी 1 और आगे तो हमारा सेम ही रहेगा. मैप का साइज़ चेक करेंगे, अगर वो किए है तो ऐसे, ठीक है. अब आई थिंक ये ठीक है. लेट मी ट्राई टू रन दिस. कहाँ पे मिसिंग है? ओके अच्छा, delete is not the method, remove is the method. Okay, now it worked fine. Let me see some solutions for this. Order of n and space is order of k. So what they're doing, they're taking a map. I think it's the same thing. Oh, get or default method. If it's present then it will get it, otherwise we'll get 1. This is a good way of writing it. Instead, let me update and write it like this. So what they are doing is, अब इट्स फाइन. करंट का ये कर दिया हमने और फिर पुट किया और इसको रिमूव कर दिया, ठीक है. दिस इज़ द सेम थिंग. लेट मी सी मोर सॉल्यूशंस. What are they doing? Wait a second. This guy is using set How is it working with set? Order of n, space is order of n. How is it working with set? एक फॉर लूप लिया है while set contains nums j, I 0 है. set dot remove nums I, sum minus equals to nums I plus plus. कुछ और ही कर दिया, कुछ कॉम्प्लिकेटेड ही है ये. ठीक है. I think this is a good solution. Let me read the next question and we'll see if we can do it today or tomorrow. Number of subarrays of size k and average greater than or equal to the threshold. Given an array of integers ARR and two integers k and threshold, return the number of subarrays of size k and average greater than or equal to threshold. Average. तो ये सब array है, इसमें सब arrays 255, 555 and 558 have average 4, 5, 6 respectively. All are greater than, all other subarrays of size 3 have average less than 4. Threshold greater than or equal to threshold होना चाहिए ना average. तो हम ये कर सकते हैं कि एवरेज अगर वो लोग कह रहे हैं, जैसे एवरेज अगर हमारा थ्रेशोल्ड 4 आना चाहिए, दैट मीन्स जो सम होगा वो 3 into 4 होगा, 12 होगा, राइट. व्हाट दे आर सेइंग इज एवरेज क्या होता है? एवरेज होता है सम ऑफ ऑल डिवाइडेड बाय नंबर ना के, इन दिस केस के साइज ऑफ सब एरे इक्वल्स टू एवरेज. और ये कह रहे हैं कि ये चीज़ जो है हमारी वो ग्रेटर देन और इक्वल टू थ्रेशोल्ड होना चाहिए, ग्रेटर देन और इक्वल टू थ्रेशोल्ड होना चाहिए TH. तो इसका मतलब जो सम ऑफ ऑल है वो ग्रेटर देन और इक्वल टू थ्रेशोल्ड इनटू के होना चाहिए. तो बेसिकली इसका सम जो है वो 12 से बड़ा होना चाहिए, 12 से इक्वल या बड़ा होना चाहिए. तो ये तो सिंपली हम 2 पॉइंटर से कर सकते हैं. बस एक चीज़ आई एम कंसर्न्ड अबाउट इज़ कि इस केस में अगर हम ऐसा तो कुछ नहीं है कि फ्रैक्शन की वजह से कुछ इशू है. सो इसमें हमारा क्या है कि डिवाइड करने के बाद अगर पॉइंट्स में आ रहा है, लेट्स से इसका सम अगर 3 पॉइंट समथिंग आता है, 1 सेकेंड. सो इसका सम अगर हमारा आ रहा है 13/4 कर रहे हैं हम, तो 4 3 जा 12, तो इसका आंसर 3 आता है. और अगर हमारा थ्रेशोल्ड 4 है तो ये नहीं पास होगा, अगर थ्रेशोल्ड 3 है तो पास होगा, राइट. तो थ्रेशोल्ड को 3 होना पड़ेगा, थ्रेशोल्ड 3 है उससे बड़ा होना चाहिए, 3 या 3 होना चाहिए या 2 होना चाहिए. अब इस केस में अगर हम कह रहे हैं कि जो सम है 13 वो हमारा 4 3 जा 12 से बड़ा है तो ये चलेगा, और 12 के केस में भी चलेगा. हाँ, तो आई थिंक दिस इज़ करेक्ट ओनली. तो हम एक ये चीज़ ले लेते हैं कि लॉन्ग, मतलब बेसिकली दैट इज़ दी ऑप्टिमल सोल्यूशन. ब्रूट फोर्स तो वही होगा कि विल चेक द सब एरे एंड विल फाइंड द for each sub-array we'll find the average by adding all the numbers and dividing it by k and check at each iteration we can check if that is greater than the threshold or not. हमको रिटर्न करना है साइज ऑफ सब एरे ना, रिटर्न द नंबर ऑफ सब एरेज ऑफ साइज के एवरेज ग्रेटर देन और इक्वल टू, ठीक है. तो लॉन्ग हमारा जो लेफ्ट राइट साइड है, लेट्स कॉल इट राइट साइड, तो लॉन्ग ये हमारा है राइट साइड है हमारा थ्रेशहोल्ड होल्ड इनटू के, राइट. अब हमको क्या करना है कि फर्स्ट इटरेशन में तो हमको के एलिमेंट्स लेने ही हैं और उनका एडिशन लेना है. तो लॉन्ग करंट इक्वल्स टू 0 और करंट के अलावा वी ऑल्सो नीड अ लॉन्ग रिजल्ट विच विल कीप काउंट ऑफ द नंबर ऑफ सब एरेज. नाउ फॉर int I equals to 0, I is less than k, I plus plus, and current plus equals to num psi. This way we found the sum of first k element. अब इस केस में भी we need to check if current is greater than equals to right, that means this is one of the results, so we'll do result plus plus. Now we'll take two pointers, int first equals to 0 and int second equals to k, as we did in previous case, and while second is greater than nums dot length, सेकेंड इज़ ग्रेटर देन नम्स डॉट लेंथ, हम क्या करेंगे, हम करंट में से फर्स्ट को माइनस करेंगे, सेकेंड को ऐड करेंगे. करंट इक्वल्स टू करंट प्लस नम्स सेकेंड माइनस नम्स फर्स्ट, ये हमारा न्यू करंट है. एंड अगेन सेम चीज़ हम चेक कर लेंगे. इफ़ करंट इज़ ग्रेटर देन राइट, that means ये हमारा एक result है, and then we'll update both first and second, so first plus plus and second plus plus, and we can return result. That's all. हाँ, ये हटा देते हैं. आई प्लस प्लस और कुछ किया मैंने गड़बड़. यहाँ क्या कर दिया मैंने, करंट प्लस इक्वल्स टू नम्स आई. क्या दिक्कत है इसमें, कैन नॉट फाइंड सर. ये अभी तक आज तक तो नम्स लिख रहे थे आप लोग, इसको अचानक से ARR कह दिया एरे को, तो बताना तो चाहिए ना. पहले हर क्वेश्चन में नम्स यूज़ कर रहे थे, अचानक से इसको ARR कह दिया. ठीक है, अब और कुछ दिक्कत आ रही है. अब इसमें क्या है, अच्छा रिज़ल्ट हमारा इंट होगा. अरे यार कितने डम्बू में, वाह इतनी मेहनत के बाद रॉन्ग आंसर. 3 आउटपुट 0 आ रहा है और इसमें 3 है, आउटपुट 1 आ रहा है. वेरी बैड. राइट निकाला है मैंने, राइट तो निकाला ही नहीं है. राइट इज़ द सम ऑफ ऑल द एलिमेंट्स, राइट तो फाइंड ही नहीं किया है, हद होती है. राइट तो अच्छा नहीं, राइट तो निकाला ही है ना. नहीं, राइट क्या है, राइट तो निकाला ही है. राइट इज़ दिस, राइट तो करेक्ट ही है. राइट सम ऑफ एलिमेंट्स थोड़ी है, राइट तो यही है, थ्रेशोल्ड इनटू के. सिस्टम डॉट आउट डॉट प्रिंटलन, राइट कितना आ रहा है, और ये चेक कर लेते हैं. और हर इटरेशन पे के करंट प्रिंट करके देख लेते हैं। करंट एक बार बाहर प्रिंट कर लेते हैं। करंट प्लस करंट, और फिर यहाँ से करंट प्रिंट कर लेते हैं। लेस देन नहीं आएगा क्या? Why I do this? I do so many silly mistakes. I'm fed up of myself. Greater than लिख रखा था, पता नहीं क्यों बेवकूफ़। Okay, this is done. Let's check some solutions. ये वाला देखें, ऐसा करें, नंबर ऑफ सब एरेज एवरेज ग्रेड, ये वाला देख लेते हैं। सेम चीज़ किया है ना उन्होंने, सेम ही लिखा हुआ है, ठीक है। दैट्स ऑल फॉर टुडे।